We're going to talk about drugs today, and maybe something that most of you never really thought about. How do life-saving drugs actually make it to the patients, right? What actually goes in there? It's first of all very complex to make them, but I'm talking here about, the GLP-1s, the Alzheimer drugs, all of these super complex molecules that is the big trend in pharma. And the one problem that they all have is because they're more complex, they're also inherently more unstable, and so therefore pharma needs a solution to actually get them safely to their patients. And that's a bit like where we're coming in when you actually look at what is the problem. We're talking it's a $35 billion headache for pharma because they're losing drugs, because they're going out of temperature ranges, because what's happening is these complex molecules have to be built in $200-300 million capex reactors. Pharma builds one, maybe two around the globe, right? And so one drug gets produced in 2 locations, but needs to go to 200 different locations everywhere. And so therefore a lot of things go wrong along the supply chain. And it also means, life-saving drugs in vaccines, about 25% of them are estimated to be worthless by the time they're getting injected into patients. So what do? We build the hardware and the technology behind enabling the safe transport of these drugs into all of these different places. Here you see 4 of our containers that are going to be loaded onto aircraft. Most of it is actually all about air transport because the shelf life of the goods is very short, but also a pallet can easily cost you 5 million, maybe 10 million in terms of goods that is sitting on the pallet. So that's what we do. We provide the hardware. We do lots of things around it so the drugs get there well and safe in time. But also we are working on reducing that CO2 footprint on getting these drugs to the various different places. So what is the market that sits behind this? So the packaging is dramatically growing. We're talking 15% year on year in terms of the growth of the market just for the packaging alone. And it's driven because the pharmacos more and more build biologics. So this is, if I look at an investment thesis, what's interesting about SkyCell is it's a derivative to the fastest growing segment of pharma without the risk attached to that. And so we're providing that. And when you look at the supply chain, so you look at all the things that are going wrong, there's all of these different handover points. So the drugs get onto a reefer truck, they get onto an airport, they're getting reloaded. And that's where we fundamentally and quite simply differentiate versus the competition. We built the technology where a large pharmaco puts their 10 million pallet into a container, seals it in their warehouse, and it's only going to get taken out at the point of the distribution. Versus, and that's where the 35 billion headache comes from, is bringing them to the airport, rehandling them, putting them on specialist containers that are built just for that flight, and then taking it out again. So, of course, it has been done in the past, but here this is a very fundamental and quite simple shift on how we reduce a huge number of products that are lost. How do we do it? 12 years in the making, like a lot of tech, 140 different patents that we have on the container itself. This container has to handle all sorts of things, right? From the vagaries in a warehouse of people driving with a forklift into it, to being on the tarmac in Dubai with 70 degrees Celsius of heat radiation onto it, or in Montreal in the winter with minus whatever, 30, 40 degrees Celsius. So the technology is built on 4 different layers. On the one side, we have specialist technologies on nanocoating that actually deflects a lot of the radiation. We worked and have patented how do we actually keep the temperature extremely stable, right? So we have 10 million worth of product in there, so how do you distribute the energy? We built essentially if you want, a chemical battery because it's all based on phase change material. So it's an extremely simple handling process, no plugging in, no manual interventions from any of the warehouse staff. So extremely simple and foolproof how to get the cargo from A to B. And last but not least, we can track it all. So the containers are fully tracked. Basically, by the time we land in Sao Paulo on an airport, we know exactly, again, what has been the journey. We can track them through airports. We know exactly where the pallets are. So working on sort of that IoT-enabled global visibility. Last 10 years, we built actually global. Right? If you want to be in this place, you need to be global. So we have roughly 30 places where we can position to the clients, but we can serve pretty much any airport around the world. We are also connected in all of these places. But pharma is very inherently like either you can do it globally or you go home. And that's part of the barriers of entry for a very, very limited set of competitors that are working in this space. But what's equally interesting is through that time, we actually built a global network of tracking. So today, we can track our containers. We have visibility of all of our containers wherever they are. And then, for example, Air France-KLM came to us and we've announced that and said, like, hey, we don't know where all of our assets are in some cases and we don't really have a solution to that. Can you help us with this? So we're having a bit of a flywheel effect here of having built for the containers a global tracking, and now we can start to apply that into other fields, and that's what we're doing today. Right? So it's a hardware tech plus software and tracking ability that we built over the years. But the challenges are only getting bigger. Right? So more biologics is absolutely the trend in pharma, so we're seeing that's where the market growth comes from. But also the weather and all of these events getting more extreme. 40 degrees Celsius in Europe, not rare anymore. And when you talk 30 or 40 degrees Celsius, that's a dramatic, almost like quadratic increase in the energy it takes to keep things cool in these fragmented supply chains. So that's, of course, the challenge that continues to be an issue. And of course, a lot of pharma also goes into throwaway, which creates piles of rubbish everywhere. And so the sustainability drive, which is a further backwind into the company's growth. How do we do it? The competition is stuck with 50% heavier equipment that is not built for this future. When you look at throwaway cardboard boxes, very small amount of cargo that can be shipped, actually flown around the world, and that is very, very efficient. And pharma is committed to this. So the large pharmacos, which is the customers that we are talking to, they want to go net zero. And they are talking about the scope 3. And that means how do the drugs ultimately get to the patient? So it's very important to them to find solutions. The way we're looking at it, and we worked with MIT on this, is when you actually deliver one pallet from Frankfurt to Philadelphia, that's 9 tons of CO2 that you typically use for one single pallet. And we can halve that footprint, so really avoidance as a first stage of saving CO2 in the atmosphere by simply 2 things. The container is a lot lighter, and secondly, we don't have to fly them back empty. Right? The industry standard, because it's such specialized equipment, has to be flown back. Ours can be transported back via sea, and that already halves the footprint. And of course, versus these cardboard boxes, you don't throw them away, but you also deliver a lot more cargo per flown air mile. It's something that pharma is very, very keen on trying to solve. Right? So the one client we were working with, they want to save 250,000 tons of CO2. We say, you move 6 lanes onto our solution, and actually you've achieved your 3 years goal. If you want to do that with direct air capture, it's going to cost you 100 million plus to do that. And on top of that, in the process, they're saving money because a lighter container obviously costs less on the cargo side for the air freight. But of course, also they don't lose any of the valuable goods in the process. So the company overall, we're growing very, very well, 50% year on year. We have, of course, our big competitor in the space that was sold in end of 2022 to EQT in a $3 billion deal. We know that they're on a 50% EBITDA margin. They have an 80% gross profit margin, 70 to 80% gross profit margin on a business model that is less well distributed than ours. We are very well establishing ourselves with large pharma, strong market growth, very high barriers of entry. It took us 10 years to get to where we are today. And of course, that also leads to a certain expectation on the unit economics. We recently raised a large chunk of additional equity, extremely well funded. Always happy to meet new friends. Of course, the story continues as we're building this company into a larger company. So thank you very much for your attention.